Article 230.71 addresses service disconnecting means. It states that a service disconnecting means shall be installed at the point of entrance of the service conductors to a building or structure. The inspector is requesting a main disconnect for the entire service because there are multiple supply points. In this case, there are the existing 3 disconnects and the new transfer switch, which means there is no single point of disconnect for the entire service. The installation described does not meet the requirement of Article 230.71 because there is no main disconnect installed at the point of entrance of the service conductors to the building. The transfer switch is not considered a main disconnect because it is only used to connect the generator to the existing service and does not disconnect the entire service. Based on this information, a main disconnect should be installed for the entire service in order to comply with Article 230.71. A main disconnect is typically a large circuit breaker or switch that is installed in the main electrical panel. It disconnects all of the power coming into the building. The main disconnect is required for safety to allow all of the power to be turned off in the event of an emergency. Understanding the requirements for service disconnecting means, as detailed in Article 230.71 of the National Electrical Code, is crucial for ensuring safe and compliant electrical installations, especially when integrating generators into a home's electrical system. The primary function of a service disconnecting means, often referred to as the main disconnect, is to provide a readily accessible and reliable way to completely shut off electrical power to a building or structure. This is paramount for safety during emergencies, maintenance, or repairs. Article 230.71 specifically mandates that a service disconnecting means be installed at the point where the service conductors enter the building. This location is strategically chosen to allow first responders or maintenance personnel to quickly de-energize the entire electrical system in case of a fire, flood, or other hazardous situations. The code recognizes that having a single, clearly identified point of disconnection is essential for preventing electrical accidents. The scenario presented involves a 400 amp service with an existing K7 meter can, a gutter, and 3 disconnects feeding the home's electrical load. The addition of a generator and transfer switch introduces a potential violation of Article 230.71 if the installation does not provide a single point of disconnect for the entire service. The inspector's concern arises from the fact that the existing 3 disconnects, combined with the new transfer switch, create multiple supply points. Without a main disconnect upstream of these devices, there is no way to simultaneously de-energize all power sources feeding the building. The transfer switch, while essential for switching between utility power and generator power, does not fulfill the role of a main disconnect. Its primary function is to isolate the generator from the utility grid and to direct power from the selected source to the load. It does not interrupt the flow of power from the utility to the existing disconnect. To comply with Article 230.71, a main disconnect must be installed at the point of service entrance, upstream of all other disconnects, including the transfer switch and the existing load disconnect. This main disconnect must be capable of interrupting the entire service, effectively cutting off all power to the building. The specific type of main disconnect will depend on the size and configuration of the electrical service. Common options include a circuit breaker housed in a main panel or a fused disconnect switch. The selection must be based on the calculated load and the interrupting rating requirements of the service. The installation of a main disconnect is not merely a matter of code compliance, it is a fundamental safety measure. In an emergency, quick and reliable disconnection of power can prevent electrocution, fire, and other hazards. The lack of a main disconnect can also complicate troubleshooting and maintenance procedures, as it may be difficult to isolate specific circuits or equipment without shutting down the entire system. It is important to note that the National Electrical Code is a minimum standard, and local jurisdictions may have additional requirements or interpretations. It is always advisable to consult with local electrical inspectors and qualified electricians to ensure full compliance with all applicable codes and regulations. Furthermore, the installation of a generator and transfer switch involves numerous other code requirements, including proper grounding, bonding, and overcurrent protection. A thorough understanding of these requirements is essential for ensuring a safe and reliable installation. In summary, the installation of a generator and transfer switch in this scenario requires the installation of a main disconnect at the point of service entrance to comply with Article 230.71 of the National Electrical Code. This main disconnect must provide a single point of disconnection for the entire service, ensuring safety and facilitating maintenance. Failure to comply with this requirement can result in code violations, safety hazards, and potential liability. In addition to the core requirement of Article 230.71, several other considerations come into play when installing a generator and transfer switch, especially in relation to the main disconnect. Firstly, the ampacity of the main disconnect must be sufficient to handle the entire calculated load of the service. This calculation should take into account all connected loads, including lighting, appliances, heating, and air conditioning. Oversizing the main disconnect is generally permissible, but undersizing it is a clear violation of the code. Secondly, the interrupting rating of the main disconnect must be adequate to handle the available fault current at the service entrance. Fault current is the amount of current that would flow in the event of a short circuit. The available fault current can be determined by consulting with the local utility company or by performing a fault current study. The main disconnect must be able to safely interrupt this fault current to prevent equipment damage and electrical hazards. Thirdly, the location of the main disconnect must be readily accessible and clearly marked. It should not be obstructed by equipment or storage, and it should be easily identifiable in an emergency. The handle or operating mechanism of the main disconnect must be readily accessible without the use of tools or ladders. Fourthly, the main disconnect must be properly grounded and bonded in accordance with Article 250 of the National Electrical Code. Grounding and bonding provide a low impedance path for fault current to return to the source, which helps to trip over current protective devices and prevent electrical shock hazards. The grounding electrode conductor, which connects the grounding system to the earth, must be properly sized and installed. Fifthly, the installation of the generator and transfer switch must comply with Article 702 of the National Electrical Code, which covers optional standby systems. Article 702 addresses issues such as the sizing of the generator, the transfer switch requirements, and the coordination of overcurrent protective devices. The transfer switch must be listed for its intended use and must be capable of transferring the load between the utility power and the generator power without interruption. Sixthly, the wiring methods used for the generator and transfer switch installation must comply with Chapter 3 of the National Electrical Code. The wiring must be properly sized, supported, and protected from physical damage. The use of approved raceways or cable assemblies is generally required. Seventhly, the installation must be inspected and approved by a qualified electrical inspector. The inspector will verify that the installation complies with all applicable codes and regulations and that it is safe for operation. It is important to schedule the inspection in advance and to be prepared to answer any questions the inspector may have. Eighthly, it is highly recommended to consult with a qualified electrical engineer or electrician during the design and installation of the generator and transfer switch system. These professionals have the knowledge and experience to ensure that the installation is safe, reliable, and code compliant. They can also assist with load calculations, fault current studies, and other technical aspects of the project. Ninthly, proper documentation of the generator and transfer switch installation is essential. This documentation should include wiring diagrams, equipment specifications, and inspection reports. The documentation should be kept in a safe place and should be readily available for future reference. Tenthly, regular maintenance of the generator and transfer switch system is crucial for ensuring its continued reliability and performance. The maintenance should include periodic inspections, testing, and servicing of the equipment. A written maintenance schedule should be established and followed. In addition to these considerations, it is important to be aware of any local codes or regulations that may apply to generator installations. Some jurisdictions may have specific requirements for permitting, noise levels, or emissions. It is always best to check with the local authorities before starting any work. Furthermore, it is important to consider the impact of the generator installation on the surrounding environment. Generators can produce noise, exhaust fumes, and other pollutants. Steps should be taken to minimize these impacts, such as installing the generator in a soundproof enclosure and using low-emission fuels. Finally, it is important to educate the homeowner on the proper operation and maintenance of the generator system. The homeowner should be provided with clear instructions on how to start and stop the generator, how to transfer the load between utility power and generator power, and how to perform basic maintenance tasks. The homeowner should also be aware of the limitations of the generator system and what to do in the event of a power outage or other emergency. By carefully considering all of these factors, it is possible to install a generator and transfer switch system that is safe, reliable, and code compliant. Remember that electrical work can be dangerous, and it is always best to consult with a qualified professional if you are unsure about any aspect of the installation. In addition to the technical aspects of the installation, it is also important to consider the legal and contractual aspects. Before starting any work, it is essential to obtain all necessary permits and approvals from the local authorities. This may involve submitting plans, paying fees, and undergoing inspections. Failure to obtain the required permits can result in fines, delays, and even legal action. It is also important to have a written contract with the homeowner that clearly outlines the scope of work, the price, the payment schedule, and the warranty. The contract should also address issues such as liability, insurance, and dispute resolution. The contract should be reviewed by an attorney before it is signed. Furthermore, it is important to have adequate insurance coverage to protect against potential liabilities. This may include general liability insurance, workers' compensation insurance, and professional liability insurance. The insurance coverage should be sufficient to cover any potential claims arising from the installation work. In addition to the legal and contractual aspects, it is also important to consider the ethical aspects of the installation. Electrical contractors have a responsibility to provide safe, reliable, and code-compliant installations. They should not cut corners or compromise safety in order to save money or time. They should also be honest and transparent with the homeowner about the scope of work, the price, and the potential risks. Finally, it is important to stay up to date on the latest codes, regulations, and technologies. The electrical industry is constantly evolving, and electrical contractors must continuously learn and adapt in order to remain competitive and provide the best possible service to their customers. This may involve attending training courses, reading industry publications, and participating in professional organizations. By adhering to these principles, electrical contractors can ensure that their work is not only technically sound but also legally, ethically, and professionally responsible. This will help to build trust with their customers, protect their reputation, and contribute to the safety and well-being of the community. Remember that electrical work is a serious responsibility, and it should be approached with care, diligence, and a commitment to excellence. The information provided here is intended for educational purposes only and should not be considered as a substitute for professional advice. Always consult with a qualified electrical engineer or electrician before undertaking any electrical work. Finally, always remember to prioritize safety. Electrical work can be dangerous, and it is essential to take all necessary precautions to protect yourself and others from electrical shock, fire, and other hazards. This includes wearing appropriate personal protective equipment, such as gloves, safety glasses, and insulated tools. It also includes following safe work practices, such as de-energizing circuits before working on them and using lockout/tagout procedures to prevent accidental energization. By following these safety precautions, you can minimize the risk of electrical accidents and ensure that your work is completed safely and successfully.